In this video, I will show you how to solve a variety of logarithmic equations. If it weren't for this 3 sitting here, I could set 2x minus 6 equal to x, right? Because the part inside of the log would equal the part inside the log. Except for this extra 3 in the way. I have to do something with that. So I'm actually going to need a little bit more space. So I'm going to write this more spread out. Okay, I've got that 3, and here's where I'm going to need the space, and you'll see why in a second. And then log base 2 of x. I need to turn this 3 into a log expression so I can combine it with the rest of the problem. I see that the base that's being used in this problem is base 2. Everything is log base 2. So what I'm allowed to put here is log base 2 of 2, because log base 2 of 2 simply has a value of 1. So I didn't really change anything. But what I can do now is the power rule, which says I can take a coefficient and move this to the exponent. So this will become log base 2 of 2 to the 3rd power. Okay, so this problem will become log base 2 of 2x minus 6 is equal to log base 2 of 2 to the 3rd power. Now 2 to the 3rd power is 8, so let's go ahead and just make it an 8. Okay, plus log base 2 of x. Now I can use the product rule to combine these, and when you have the sum of 2 logs, they combine using multiplication. So this will be log base 2 of 8x. Alright, addition condenses down to multiplication. Meanwhile, over here I have log base 2 of 2x minus 6. Now that I have a single log equal to a single log, both base 2, then the argument must be the same. The stuff inside the logarithm must equal the stuff inside the other logarithm. So in other words, 2x minus 6 must equal 8x. So now it's just a matter of solving Algebra 1 style. So to avoid getting 0 over here, which confuses students often, I will subtract 2x from both sides. So that will give me negative 6 is equal to 6x. Okay, then when I divide both sides by 6, it's easy to see that I'm going to get x equals negative 1. And that is the final answer. Except for one thing. When you're solving a logarithmic equation, you have to make sure that your solution does not have you taking the log of a negative number. Alright? You can't take the log of a negative number. There's no exponent that's going to change 2 into a negative number. So if I were to substitute this negative 1 in right here, I would get an undefined expression. You can't take the log base 2 of negative 1 is impossible. Also, if I were to substitute negative 1 back in right here, that would be negative 2 minus 6, that would be negative 8. You can't take the log of negative 8 either. So the only solution that we came up with is actually what you call extraneous. Alright, meaning it doesn't actually work when you plug it back in. If we had 2 solutions, then I would go with the one that was left. But since this was our only solution, guess what we're going to say? We're going to say no solution. So that is the actual answer to problem number 1. So something to look out for. And again, a value that doesn't actually work is called extraneous. And some students, when they learn that word, they want to write that word as the answer, but it is not. It's just an adjective describing a possible solution that failed. But the answer is no solution. Maybe we'll have better luck with number 2. I am going to use the same strategy. So By the way, this is understood to be base 10. I'm not sure if that's going to end up being important later or not. So I have log x equals 1, and I'm just going to leave a little bit of space, minus log of 2x minus 3. So I'm noticing that we're using base 10, which you don't write the 10. So if I were to do log base 10 of 10, which is what this is, that has a value of 1, so I'm not really changing anything. So that's what I'm going to do. Alright, so fine. So now I have log x equals log 10 minus log 2x minus 3. So even this 1 in the front, I don't really need anymore. Okay, so I'm just going to ignore the 1 because I could erase it. So what I am going to do is I will use the product rule, which says, no, I see the minus sign. This will actually be the quotient rule, which says if you have the difference of two logs, subtraction, this will condense down to a single log of division. So I'm going to have log of 10 divided by 2x minus 3. Okay, that's the quotient rule. So now that I have log of something equals log of something, the arguments must be equal. The stuff inside must be equal. So that means x must equal 10 over 2x minus 3. So now I just need to solve this for x. So I would multiply both sides of the equation by 2x minus 3. Alright, over here these will just cancel each other out. On the left side I'm going to have to actually do the distributive property. So that's going to give me 2x squared minus 3x is equal to 10. Subtracting 10 from both sides. Okay, I think I'm going to bring this up so I have more room. So now I will have 2x squared minus 3x minus 10 is equal to 0. Now maybe this is factorable. I'm not sure yet, but let's try. If it is factorable, 2x squared can only be 2x times x. Now 10, that's either 2 times 5 or 10 times 1. Let's start with 2 times 5. The 2 will definitely not go here, because that would make a common factor. If there's no common factor in the previous step, there shouldn't be a common factor in either one of these parentheses. So instead of putting 2 times 5, I would go straight to 5 times 2. Now, the inner plus the outer must equal the middle. Inner, I have 5x. Outer, I have 4x. Can I get a 3 out of that? No, I cannot. So this is not working. The 2 and 5 option is not working. So I will try the 10 times 1 option, but it's not looking good. Okay, and in fact I can't put the 10 here because again I'd have a GCF. If I put the 10 out here, that's going to make 20 and 1, so that's not going to work. So this is unfactorable. So that means I'm going to have to do the quadratic formula. So, my answers will be ugly. But, what are you going to do? Got to do what you got to do. So for starters, anytime I do the quadratic formula, I like to do the discriminant first. So just to remind you, the quadratic formula works like this. X equals the opposite of b plus or minus the square root of, and then under the square root we have b squared minus 4ac all over 2a. That's the quadratic formula. The b squared minus 4ac part is called the discriminant. So I recommend that you find that first. So the discriminant is going to be 9, b squared, so that's going to be 9 minus 4 times 2 times negative 10. So that's going to be 9 plus something. See, I see we have a negative times negative, so that's going to be a positive. Anyway, 4 times 2 is 8, times 10 is 80. So the discriminant is 89. That's the discriminant. So getting back to writing the actual solution, so x is going to equal the opposite of b. Alright, so that'll be positive 3 plus or minus the square root of 89, there's my discriminant, all over 2a. So that's going to be 4. Alright, 89 cannot be simplified any further. So there's nothing else we can do with this. It can't be simplified anymore. So this is the answer, if we want an exact answer. So I suppose if we were asked for a decimal approximation, I could go further using my calculator. Alright, let's do that just for fun. Fraction mode, I could do 3 plus the square root of 89 over 4. Okay, hit this button for the decimal. So that is, whoa, I wasn't ready for it to disappear. 3.11. Got to round up. I'm doing the nearest hundredth. So 3.11. Okay, and then for the other decimal, I'm actually going to try to go back and just change it to a minus sign. Okay, so negative 1.61. Alright, so this would be the decimal approximation to the nearest hundredth. So that's how you do problem number 2. Alright, let's try the same strategy on number 3. So I will start by spreading things out a little bit. Alright, here's where I'm going to leave the space. Alright, negative log base 9 of x. So the first thing I'm going to do is I see that we're dealing with base 9. So I'm going to write log base 9 of 9 because I know that has a value of 1, so I didn't change anything. I'm also going to use the power rule because this is really like a negative 1. And what I can do, if this is a negative 1, I could move this to the exponent and have this be like the negative 1 power. Alright, so I'm going to do that. Eventually I'm going to have to deal with that. But for now, I'm just going to see how far it goes. So, what now? For my next trick, I'm going to take this 2 and I'm going to move that to the exponent as well. That's going to make this an 81 because it'll be 9 squared. Okay, so now I've got log base 9 of 9x minus log base 9 of 81 is equal to log base 9 of x to the negative 1 power. So I can combine these using the quotient rule, which says I can write a single log. When you have subtraction, it will condense to a fraction. So this will be log base 9 of 9x over 81, which is equal to log base 9 of x to the negative 1 power. Now seems like a good time to go ahead and deal with the x to the negative 1 power. We know that x to the negative 1 power is the same thing as 1 over x. So let me just start writing that. Okay, now that I have log base 9 of something equals log base 9 of something, I can set the two somethings equal to each other. The arguments are equal. Now, as I copy this down, I might as well reduce this fraction. 9 goes into 81 9 times. So this is going to be the same thing as x over 9. Okay, and now here I'm bringing down the 1 over x. So I've got this. So to solve this, I would simply multiply both sides by x. You know, I mean, I could cross multiply, which is what I really am doing. Alright, if I multiply both sides by x, that cancels this out. Okay, and that's going to give me x squared over 9 is equal to 1. And then I could multiply both sides by 9. Alright, so look, if you're familiar with cross multiplying, you could do this in one step and just do x squared is equal to 9, which is what I'm about to get. Okay, so either way, you end up with x squared is equal to 9. Taking the square root of both sides, I'm going to get x is equal to plus or minus 3. Don't forget the plus or minus. That's two solutions for the price of one. Okay, now we need to look back and watch out for extraneous solutions, because understand that this means x is equal to 3 or negative 3. But you cannot take the log of a negative number. So negative 3 is not a valid answer. It is extraneous. And put a big ol' x through that one, because I mean this alone, I just have log base 9 of x, so x cannot be negative 3. That's a log of a negative number. But 3, positive 3 is okay. Alright, 9 times 3, positive 27, everything's fine. So x equals 3 is our only solution. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.